Hello, I'm Phil McCaffrey, and welcome to 8:30 Prep. I think I'm going to change the name of this to Quarantine Prep. I'm sorry if anybody's clicked on the wrong link because I hit the wrong button. So hopefully a few of you have found your way to my presentation. I sent out an email to all my students and parents and to the counselors and included a link to the one I started live, so I screwed it up. This is 8:30 Prep, calling it Shark Week. Just kidding, it's Geometry Week. We're going to go over a whole bunch of geometry on the ACT. The ACT is heavier in geometry than the SAT. The old SAT that I always talk about that I love so much died in 2016, 4 years ago. It had a lot of really fun geometry on it. But the ACT still has a really good amount of geometry, and it's really easy. So the SAT geometry, out of 58 questions on the SAT, there's usually only 2 or 3 geometry. On the ACT, there's a bit more. Let's go, Geometry Week. Thanks, Alex. All right, so Alex, big shout out to you. Shout out to Alex. So I promised Gavin. Gavin asked a question that's going to be covered now on Wednesday for circles. So what are we going over this week from Monday, Tuesday, Wednesday, Thursday? Today is lines, angles, and triangles. Then we're going to do polygons and quadrilaterals, circles, and then solids and multiple figures. No, without hesitation, let's talk about a line. A line has 180 degrees. There is almost always the 180 degree question on the ACT, but they have this little trick that I found that works out every time. So even though this is a number 4 and it's relatively easy and it's 180 degrees, it says E is on AD, EB is perpendicular. I just wanted to put it on there because perpendicular counts. It's 90 degrees. This symbol is 90 degrees. What is CED is 38. What is AEB? The thing I love to do on this one is it's 180 degrees, and this is 90, and 38 ends in 8. So the answer has to end in 2. The answer has to end in 2. Look how nice the ACT is. They only gave one answer that ends in 2. This question literally asks 8 plus blank equals something that ends in 0. 2. I call this last digit math. Works out incredibly well for triangles. All right. Another thing about lines is the famous parallel lines cut by a transversal, where there are 2 angles and they add up to 180 degrees and their vertical angles or opposite angles are equal. So here we have 2 parallel lines cut by 2 transversals, and one's 55 degrees. It's a number 1. Folks, the answer is 55 degrees. You should know this one and know it really, really well. Same question comes up almost every time. This line where N is parallel to M and it's cut by a transversal, it says, of which of the following statements, when it is true, cannot always be used to prove that the lines are parallel. To prove that the lines are parallel, we need that opposite angles are congruent. What they're asking here is look for ones that are congruent but are supplementary and complementary at the same time. So let's go through this. 1 is equal to 5. That's true. 1 is equal to 7. Not true. If 1 is equal to 7, that does not, if 1 is congruent to 7, that doesn't prove it. Let's go through the rest of these. 1 is equal to 8. 2 is equal to 7. 4 is equal to 5. Yep, it's 1 and 7. 1 and 7 cannot be congruent. All right, now here's a great question. In the diagram below, M and N are cut by a transversal. That's why I wanted to put it on there, was that word. A transversal means this line here, cut through it. But M and N are not parallel, so which of the following statements must be true? So what we're looking for is 1 is equal to 2. This sign here, this equal sign with the line above it means of equal measure. It means congruent. In strict math terms, angles aren't equal, they're congruent. Because to be equal, they have to be equal. They have to be the same exact angle. So this is a weird math thing. The squiggly line by itself means approximate. So this is approximately equal or congruent. So 1 is congruent to 2. What must be true? Nope, that doesn't have to be true. 1 is congruent with 3. That must be true. 1 congruent to 5, they're not parallel. 2 congruent to 6, they're not parallel. 3 congruent to 5, they're not parallel. The answer is 1 and 3 because they're vertical angles. Here we are going to switch, I can speak English, from lines to triangles. This is a famous problem. You did it in geometry class, and that is the two outside angles are equal to this angle. The sum of 35 and 115 is equal to this angle. That's because this angle x is equal to 180 minus 115 plus 35. Well, so is angle ACD. And let's use last digit math. 5 plus 5 ends in 0. This has to end in 0, so this has to end in 0. How many of the answer choices end in 0? 2 of them, but one is 120, and this is 115 plus 35, which is 150. So last digit math works pretty good, and we could estimate and get there. All right, in the figure below, the measure of XAB is 150. The measure of YCB is 81. X, A, C, and Y are collinear. Great word. That means they are on the same line. This is the famous line and triangle problem that, sorry, my nose is running. Uh-oh, hope I don't have any symptoms. What the collinear means, they're on the same line, meaning that these two angles are supplementary. That's a shout out to Nate. And let's take a look here. So this one has to end in 0. This one has to end in 9. So this one has to end in 151. Let's add them up. This is 30. This is 99. 30 and 99 and 51 make 80. 180. We're good to go. And lines B, C, and D, E are parallel. Love the word parallel. And transversals BD and CE intersect at A, as shown in the figure below. Given that ABC is an equilateral triangle, notice triangles and lines flow together often on the ACT. We have an equilateral triangle, parallel lines into transversals. This is 60. That's a supplementary angle. It's 120. Nate, I am definitely sending this off to you. You have to watch it. The answer is 120. Nate Amsataquis was my geometry co-teacher way back when, about 10 years ago, and we used to always walk around and go, supplementary angles. It's really, really bad. The students hated it. I'm sure you will too. The dimensions of the right triangle shown below are in feet. Who cares? What is the area in square feet of the triangle? 1/2 base times height. Let's do 1/2 times 2x plus 2 times x plus 4. Wait a second. It's a quadratic. This is the base, and this is a height. And it's a quadratic that's not a difference of the square, so it's going to have 3 terms. Oh, it's a number 15. Only one answer has 3 terms. And sure enough, it's x squared plus 5x plus 4. Let's cancel out the 2's, and I get x plus 1. And let's FOIL it, and let's get x squared plus 5x plus 4. We're good to go. That's the right answer. Carrying on with triangles. In the figure below, AC and BE intersect at D. What is the measure of EAD? EAD? Well, let's see. This bad boy's a triangle. They give me here. So in purple, I have a triangle, and I got a 0, a 0, a 3, I need a, I didn't even know this one was a last digit math. I just tried to check it out. I do this one all the time. The first thing I look for is there just one number that makes it work? Let's add this up. 83 and 30 and 50 make 133 and 47 make $1.80. I love last digit math. It is more fun to cheat. Or, that's not cheating. Do you think that's cheating, Teo?
That's not cheating.
That's not cheating. So, a shout out to Gavin too. Teo made a sign for me. Thanks for sending the question. Oh, I already gave him a shout out, didn't I? Don't forget the meme of the week. Nobody sent me a meme. 3R Prep on Instagram. Supplementary angles. So there we go. Teo sent me a meme, so there is a meme on there. In the isosceles right triangle, I'm picking out problems to teach vocabulary. Isosceles right triangle. Isosceles means the two sides are equal, so this is 10. And you should know side times the square root of 2. 10 times root 2. It's not an answer. But I could put 10 on the inside of this square root. By squaring it, I can have the square root of 2 times 100, which is equal to 200k. The other one you should absolutely know is the 30, 60, 90. And the 30, 60, 90 has a short leg of x, a hypotenuse of 2x, and a long leg of x root 3. Definitely should know that right triangle. We're going to come up to the famous 3, 4, 5 here shortly. Yep, here's one. This is off the current official practice test of the ACT, the 1874. Meaning it was test number 74, printed out in 2018. The ACT prints an official practice test every 3 years. I have them going back 6 sets of 3. So how many years does that make? All the way back to 6 sets of 3. Oh, man, like 2000 something? Yeah.
2002.
2000.
18 years ago.
Yeah. It's pretty far. It's pretty far away. It's like 2000. Let's see. So this would be 2018. Then we got the 15, and then the 12, and then the 9. This is the 9, and then the 6. So 2006. 1, 2, 3, 4, 5. 2003. That was when they came out. Yep. I think the 59 is from 2003. So we've got them on our website. It's under Student Resources. If you go to 3rprep.com, Student Resources. And here's the famous 3, 4, 5 triangle. When you see a right triangle, look to see if the sides are multiples of 3 or 4. This is 4 times 8, and this is 3 times 8. That makes this 5 times 8, or 40. So I don't have to do the Pythagorean theorem. And it wants to know the midpoint of the hypotenuse, which is 40, and the midpoint of 40 is 20. One of the favorite words on the ACT, let me throw that one in there, is midpoint. And midpoint, as we've done in the formulas, is the same as halfway. They give us equal sections, and they bisect. And if you're given the coordinates, they're the average of the coordinates. So the ACT takes these terms here and makes them the same concept. They are equivalent, is the ACT word. The length of the corresponding sides of two similar, that's why I picked this one, similar right triangles are in the ratio of 2 to 7. Similar means that sides are in ratio, but the angles are equal. If the hypotenuse of the smaller triangle is 10 inches, how many inches is the hypotenuse of the larger triangle? So the larger triangle, 7 over 2, is equal to the bigger triangle's hypotenuse over 10. So let's multiply 10 this way. Divide by 2, I get 5 times 7, or 35. The lengths of the corresponding sides of two similar right. Wait a second. I just read this problem. Let's go back. A number 27, and then a number 28 with the exact same words. What does this mean? This means the ACT absolutely repeats wording. This wording is so perfectly true that the sides are in ratio of 7 to 4, and they want to know the bigger side. And I'll multiply it over here and divide by 4 and get 35. Same question, same answer, two different tests. What's going on, ACT? Come on, be original. What this means is you can get a higher score by practicing. Let's try to get to some two triangles are similar. The shorter side is 9 inches long, and the shorter side of the larger is 16 inches long. The perimeter of the smaller is 36. What is the perimeter of the larger? This is the larger is 16 over 9 equals x over 36. We just did two of these. Let's speed along. That's how you set that one up. Marcia is making a sail for a model boat. In the figure below, the sail is represented by triangle ABC. Base BC is 18 inches long, and the legs A, B, and C are each 15. So this whole thing is 18. That makes this 9. If the mast is perpendicular and the base extends 4 inches below the bottom, how long is the mast? That means add 4. So we've got to have 9 squared plus 15 squared square root. That's not a Pythagorean triplet, so it's got to add 4 on the bottom. I'm guessing the answer is E. I haven't done this one out, so let's do it. Ready? Let's do 9 squared plus 15 squared. Enter. Second function. Square root. Answer. Backspace. Second function. Answer. The square root is 17.42. Let's do 3 times the square root of 11. I haven't done this problem in a long, long time. 3 times the square root. Nope, that's not right. What am I doing wrong here? 3. Oh, dude, that's the hypotenuse. This is the 3, 4, 5. 3 times 3, 3 times 4, and 3 times 5. I really messed that one up. So this is 12. 12 plus 4 is 16. Man, they made me jump on this bad boy because I did this wrong. So this is 15 squared equals 9 squared plus the mast squared, b squared. And it is a 3, 4, 5. Ugh. I should have practiced this before I did it. Oh, thanks for being dedicated viewer, Gavin. Oh, 13. Counts as ACT prep. Yes, it does. Gavin, my boy, is going to get a massive scholarship to college. The hypotenuse of POM is PM. So POM, I'm going to put a P here, an M here, and an O here. Which of the following statements could be true? MO is equal to OP. That could be an isosceles right triangle. MP is equal to PO. No, they're not congruent because the hypotenuse is always longest. M is a right triangle. No. Right angle. O is no. The 3 sides are congruent. No, that's an equilateral, not a right triangle because of the word hypotenuse. The 3 are congruent. No, that is a equal angular, which is an equilateral. So the answer is F. I really should practice these before I do this 8:30 prep live, shouldn't I? One of these days I will. I just made this morning. ABC and DEF are similar triangles such that the scale factor is 2 to 3. The perimeter is 20 inches. What's the perimeter of DEF? 30. 2 to 3. 20 to 30. Whoop. What? What? Don't do that. All right, one of my favorite problems. While lifting weights, a person sits on an inclined weight bench and puts the weights straight up, shown in the figure below to the left. The weight bench is shown below on the right. The angle between the seat and the backrest is 110 degrees. What is the measure of the angle between the backrest and the vertical path of the weights? Dude, what is this angle between this vertical path? Well, let's draw a right triangle. So this is 90 degrees. This bad boy is 110. So the outside is 90 plus 110. No, this is 90. 80, 70. So this is...
We can do math.
I can do math. 180 minus 110 is 70. And what do I need here? 20. So this is 160. There we go. Woo. It is a hard problem. Students ask me to do this one all the time, and I used to fly through it. Now I know why it's so confusing. This is a 44. The last 20 are the hardest, and they're usually wordy, and they've got goofy symbols, but this is still a triangle. All right, in the figure below, lines, this is on 55. Let's see me screw it up. Lines A and B are parallel, and the angle measure Y is in degrees, and 1 and 2 have the same measure. That means these bisect. That means they're a half of a Y. Which of the following is equivalent? Whoop, I got to shrink this bad boy down so I can get some answers to be shown.
Didn't even know there were answers.
There wasn't even answers. ACT is always multiple choice. So let's erase. All right, I am coming to the end here. Let's see. So this is bisected. Which of the following is equivalent to the degree measure of root 3? Angle 3. Let's see. So this is 180 minus y. And this is plus y over 2. That's going to be that angle there. And then the whole thing, 3, is going to be 180 minus this. So let's change that to a plus and this to a minus. It's going to be y over 2. Are they equal? Yep. Going to have to work that one out again. In ABC, the measure of angle A is 43 and the measure of C is 32. Which of the following inequalities involving the lengths of the sides? I wanted to do this one because, let's see, let's draw, this is acute, 43. So this is, let's call this one 43. That's pretty big, 43. And this one is 32. And so what's 32 plus 43 is going to give me 75. And 180 off of 75 is going to give me 105.
Oh, it's definitely 105 degrees right there.
Yeah, bad boy. So
way over 90 degrees for sure.
So this is the biggest side. So what do we say? A is 43. C is 32. B is 105. So what do we have to say is this is the shortest side. This is the second longest side. And this is AC's got to be greater than, AC has to be greater than CB, which of the following is true? AC is greater than BC. Yeah, what they show here is AC is greater than AB plus BC. That's the other way around. This is actually AB plus BC must be greater than AC. This is, if I have a triangle, and let's throw that in as a lesson, sides A, B, and C. Any two sides, the sum of any two sides must be greater than the third side, or you don't have a triangle. 52, which of the following sets of 3 lengths in decimeters are the lengths of an obtuse triangle? Obtuse. I love that word. It rarely, if ever, comes up, acute and obtuse, but it does come up. Both of them come up. So this is a 3, 4, 4 isosceles. That is not obtuse. 3, 4, 5, right triangle. That is not. 5, 12, 13, right triangle. Know that one. Very good one to know. 6, 8, 9 is also 6, 8, 10 would be a right triangle, so it's acute. 6, 9, 13. That's got to be obtuse. And do I have one more left? That was it. That was triangles on lines and angles. How far did we go? Pretty far. 34 minutes. Really long one. Somebody emailed me today. Be rational. Thanks, Alex. Get real is I and pi. Very good. Somebody emailed me today saying how long this would go. This was a pretty big one. Lines, angles, and triangles are a huge part of it. Tomorrow is quadrilaterals and polygons. Won't be as long. Wednesday is circles. Thursday is solids and multiple figures. I'll see you tomorrow night for 8:30 prep.